As you can see in front of yourself, the screen has been shared and the book. Let me just magnify it for you to make it easy to read. Okay, before I move on to the actual content for today, do I need to repeat this flowsheet diagram? इसमें से कोई भी step इस diagram में इसमें से कोई भी problem?
No, sir.
All right, understandable. Now, what I need you to do is to write a couple of things or helpful material for yourself. What I'm going to do is that I'm going to discuss the past paper content in terms of this process. इस process के बारे में जो past papers में है, उसमें हमारे पास क्योंकि हमारा structured paper होता theory paper, लेकिन उसमें कुछ extensive questions ऐसे आए हुए हैं past में जो इस पूरे process को एक साथ पूछने की कोशिश करें. So what I'm going to do is that I'm going to make a few steps out of this flowsheet diagram in order to make it easier for you to write the exact answers in the questions that come from past paper in step form. All right, this is going to be the first step. Second, okay, let me do it in another way. Let me keep stamping it. Step number 1 with a blue arrow. Step number 2. Step number 3. And this for this which the equation is not written, this is step number 4. These steps usually come as a 4 to 5 mark question. Usually the short question in IGCSE chemistry theory paper 4 are not 4 to 5 marks, 2 marks, 3 marks, that's about it. When if the question is around 4 to 5 marks for the same process, that means the question has higher importance or content rate. Okay. So these are the steps that you need to write. Sometimes the student get confused that do we need to write what's written on top, or do we need to write this mixing of gases or cleaning by electrostatic precipitation as a process? Do we need to write this unreacted gases recycling as a process? No. Actually, you're supposed to make 4 steps out of this process. Step 1 is this. I think you should write that on your book. अपनी book पे लिख लें ये step 1 होगा, ये step 2 होगा, ये step 3 होगा. इसमें भी और वाली क्वेश्चन नहीं आएगी, आप टॉप वाली क्वेश्चन लिख लेंगे. ठीक है ना? कल मैंने आपको कहा था कि टॉप वाली क्वेश्चन पर लिख लें न्यू मेथड और नीचे ब्रैकेट वाली क्वेश्चन पर लिख लें ओल्ड ऑब्सलीट मेथड. ठीक है, ऐसा मेथड जो यूज नहीं किया जाता. ऑब्सलीट मींस समथिंग दैट इज नॉट यूज्ड एनीमोर. ठीक है. और लास्ट स्टेप के लिए हमारे पास एक क्वेश्चन नहीं थी. I asked you to write the equation yesterday. So the 4 steps I'm talking about are actually 4 equations here. The first one is sulfur with oxygen giving us sulfur dioxide. The second one is the major equation concerning Le Chatelier principle with a number of conditions also mentioned over here. So sulfur dioxide is further reacting with oxygen to produce sulfur trioxide. It is then reacted with sulfuric acid in order to produce oleum. I asked you to write oleum in front of H2S2O7. And in this case, there was a separate equation that I wrote on the book yesterday. That is oleum plus water gives us 2 molecules of sulfuric acid. I hope we are all on the same page. You have written the steps, you had noted down the equations or extra hints that you need for to solve the questions that we have seen in past papers. Are we all on the same page? Who confused nahi hai beta? If there is any confusion, if there is anything missing जो आप लिखना भूल गए हो या कोई step ना समझ आया, you may ask right away. All right. If that's clear, moving forward. Yesterday I talked to you that sulfuric acid is considered as king of chemicals because most of the chemicals are made with the help of sulfuric acid. If not a direct reaction with sulfuric acid is however used for many other purposes, as a side reactant, as a catalyst, as to give acidic environment, as to decrease the pH of those reactions. So we use sulfuric acid to make soaps and detergents. This was previously a part of the book, but it has been removed from your course after 2016. Leather and tanning will be a part of A levels. Fibers and dyes, we'll consider that in chapter number 11. Fertilizers, we have already considered that before. Paints and pigments, not to be considered in this book. Chemicals and plastic, we'll consider that hopefully in chapter number 11. And cleaning metal, something we have considered back in chapter number 8. Clear? So all the arrows, this entire uses of sulfur is something that either we have discussed before or we are going to discuss in upcoming chapters. There are a couple of things that we discuss here, not at all, not in this book, but in A-levels book that I've also explained as well. These are the uses of sulfuric acid. Now, coming to today's topic. Today's topic was starting from the properties of sulfuric acid. So sulfuric acid is present in two forms, concentrated when it's not mixed with water. Let me tell you a few things about concentrated sulfuric acid. Okay. First of all, please note it down. Okay. So, are we clear? Concentrated sulfuric acid has an oily appearance and it is slightly yellow in color, slightly, just like the oils appear to be a little bit yellowish or orangish. Okay. It appears the same. Do we get that point? Are we familiar with oily appearance? The appearances are of two kinds, watery appearance, oily appearance. Okay. वो हमारे यहाँ बच्चे होते हैं पुराने जमाने की माएँ जो होती थी वो बच्चों को जब तैयार करती थी तो बालों में ढेर सारा तेल डाल के फिर उसे ऑयली सी appearance दे देती थी. Although this is a funny example, but it has the same appearance. See? And most of the oils, whether it's an edible oil or it's a hair oil or it's an oil for machine purposes, they usually have a yellowish brown, a slightly yellowish brown appearance. It has the same appearance. So, number one, it's a powerful dehydrating agent, right? Do you understand what dehydrating agent is? Can any of you answer the question what a dehydrating agent is? If you don't know, you can say it straight away, that's fine. I'm actually asking this question because I'm assuming that you might know it from biology, dehydration or diseases that come with dehydrating symptoms, something like that. Very good answer, Rafe. Rafe ne chat mein iska answer diya, something that removes water from a substance. So dehydrating agent, let me clarify, hydrate means to add water. Dehydrate means to remove water. मैंने बायो का तो रेफरेंस दिया लेकिन बेटा थोड़ी सी शर्म करें हमने इसे चैप्टर नंबर 5 में पढ़ा था हाइड्रेशन और डिहाइड्रेशन को so it shouldn't be a problem आपको पता होना चाहिए dehydrating agent is a chemical that can remove water from any substance so it's a very powerful dehydrating agent it can remove water from any substance and that's why sulfuric acid is corrosive for our skin okay I don't know whether you have seen it or not it's not a good sight but किसी लिविंग थिंग के ऊपर इंसान के ऊपर स्किन के ऊपर अगर एसिड गिरा हो तो आप देखते हैं कि वो स्किन ब्लैकिश अपीयरेंस देना शुरू कर देती है या डार्क ब्राउन ब्लैक अपीयरेंस देती है that's because sulfuric acid is corrosive but on our skin it also acts as a powerful dehydrating agent now if we talk about human body 60% of entire human body is made out of water the water is present in almost every cell in the body okay what it does to that living cell is that it takes the water out of that cell. Hence, the cell is left out of water. So, hence the brownish black appearance after the acid has reacted. And that appearance is not good. अगर आप देखा हो किसी ऐसे victim को जो acid victim हो या accidentally किसी के ऊपर acid गिरा हो, ठीक है, तो आपको अंदाजा होगा कि ये साइट अच्छी नहीं होती, ठीक है, वो स्किन कलर भी अच्छा नहीं होता, समटाइम्स तो देखा भी नहीं जाता, ठीक. I hope that is understandable. The next thing that we have over here is a powerful oxidizing agent. So ये तो हमने definitely chapter 4 में पढ़ा है, chemistry में भी पढ़ा है. So हम थोड़ी सी memory joggle करते हैं and let's see if the boys can answer it. But Rafi is an exception. Rafi cannot answer. You've already answered a question. So the rest of the boys.
So it means oxygen add करता है सर उसमें.
Yes, very good. ऑक्सीजन ऐड करता है, तो ऑक्सीजन ऐड करने वाली चीज को हम ऑक्सीडाइजिंग एजेंट कहते हैं या रिड्यूसिंग एजेंट कहते हैं.
सर रिड्यूसिंग एजेंट.
Reducing agent sir. Sorry sir.
सर ये सर ऑक्सीडाइजिंग एजेंट वो बस जो इलेक्ट्रॉन्स को सर रिमूव करे फ्रॉम अदर रिएक्टेंट्स ड्यूरिंग अ रिडॉक्स रिएक्शन.
नहीं, हम इस वक्त ऑक्सीजन के हिसाब से बात कर रहे हैं. सो यू माइट बी राइट अबाउट इलेक्ट्रॉन्स. मैं इसके ऊपर कोई कमेंट नहीं कर रहा, रिजर्विंग द कमेंट राइट अवे. जस्ट टॉक अबाउट इन टर्म्स ऑफ ऑक्सीजन. मुझे ऑक्सीजन के टर्म्स में एक्सप्लेन करें. वासिन ने एक आंसर दिया, वासिन ने आंसर चेंज कर लिया, आप एक आंसर दे रहे हैं, लेकिन मुझे आंसर दें इन टर्म्स ऑफ ऑक्सीजन, whether it will add oxygen to a substance or remove oxygen out of a substance.
सर वो अपने से ऑक्सीजन उसका अपना खत्म हो जाता है और किसी और में चला जाता है.
ये ऑक्सीडाइजिंग एजेंट की डेफिनेशन है, राइट?
यस सर.
Okay. So let me tell you, Ayan, you weren't correct. Shazeb is correct. Wasi was correct at start, but Wasi ने फौरन आपको देखते ही confuse हो गया और अपनी statement change कर ली. Wasi आप शुरू में ठीक कह रहे थे. I was just trying to see कि आप confuse होते हैं या नहीं होते. Ayan, ऑक्सीडाइजिंग एजेंट बेटा वो ऑक्सीजन ऐड करता है अपने अंदर, नहीं किसी दूसरे के अंदर. If in order to elaborate it, तो उसके बाद खुद के पास ऑक्सीजन एटम्स होते हैं, जिस तरह शाहजेब ने एक्सप्लेन किया कि उसके अपने ऑक्सीजन एटम्स रिमूव हो जाएंगे और किसी और में ऑक्सीजन एटम्स ऐड हो जाएंगे. इन टर्म्स ऑफ ऑक्सीजन अगर हम इलेक्ट्रॉन्स के हिसाब से बात करें तो किसी को इलेक्ट्रॉन्स हम जिस तरह से कहते हैं ऑक्सीडाइज करता है और ऑक्सीडेशन इज लॉस ऑफ इलेक्ट्रॉन्स, तो हाँ वो किसी और से इलेक्ट्रॉन्स रिमूव करेगा और प्रोबेबली अपने अंदर इलेक्ट्रॉन्स ऐड कर लेगा. सो ऑन द केस ऑफ इलेक्ट्रॉन्स मैं उस वक्त कमेंट रिजर्व कर रहा था, लेकिन बट यू वर राइट. But in case of oxygen you weren't correct, ठीक है, तो उसके अपने ऑक्सीजन कम होंगे और वो किसी और में ऑक्सीजन ऐड करेगा. As you can see the formula of sulfuric acid here, I'm going to give it a blue arrow. ये डायग्राम के सेंटर में जो सर्कल है इसमें आप blue arrow में देखेंगे कि it has 4 oxygen atoms, so it's easy for it to give oxygen to something. So ये oxidizing agent के तौर पे behave करता है. Not just that, it can also take up electrons from that thing to oxidize it, और ये खुद एक जो ना रिडक्शन के प्रोसेस में जाता है, ठीक है. तो it means the same thing whether we explain it in terms of electrons or we explain it in terms of oxygen, ये ठीक रहता है. Now boys, you're going to stay quiet, and girls, you're going to answer me for the next point over here, that it is very corrosive. Now I've explained the word corrosive in terms of human skin or in terms of living cells. How would you explain it in terms of non-living things? Guns, can you explain me in terms of metals or non-metals or other non-living material? How is it going to behave with that non-living material? Or what does the term corrosive here means? Girls? Do we even have girls in class? कौन है यहाँ पे, कौन है? We only have Tanisha and Zoha here. Okay, तो हमारे पास ऐसे भी क्लास में थोड़ी सी गर्ल्स होती हैं. तो Tanisha and Zoha, no idea.
Sir, can you please repeat the question?
corrosive का मतलब नॉन लिविंग थिंग्स के केस में क्या होता है. मैं ह्यूमन स्किन के हिसाब से बता चुका हूँ. ह्यूमन स्किन डिस्ट्रॉय हो जाती है, ब्राउन ब्लैक कलर को चली जाती है, ये उसमें से वाटर रिमूव कर देता है, तो इससे वैसे भी बहुत बुरे होते हैं ह्यूमन स्किन के लिए. व्हाट अबाउट इट बीइंग corrosive फॉर नॉन लिविंग थिंग्स? किसी मेटल के साथ या किसी नॉन मेटल के साथ ही क्या करेगा? What does the word corrosive here means in terms of metals or in terms of non-metals? This question is both from Tanisha and Zoha. and any other boy in the class who considers himself as a girl. Gee. Now the boys are going to be dead quiet. Gee, girls, come on, come up with some ideas. You're not going to stay quiet. And if you have no idea, just say it straightforwardly so as not to waste time. कोई मसला नहीं है अगर आपको याद नहीं है हम बहुत अरसे बाद केमिस्ट्री की बुक को हाथ लगा रहे हैं. It's not a problem.
Sir, maybe it can melt a metal.
Maybe it can melt a metal. Good idea. But to melt a metal, we need heat. So हमने कहीं पर भी इसे कोई exothermic agent नहीं लिखा. तो no, corrosive does not mean कि ये heat करेगा. Go, आपका idea ठीक है, ये heat produce करता है after some specific reactions. But first we'll talk about those reactions and then any other, we can say, effect in terms of heat with those reactions. You're correct at one point, but it still needs a prerequisite explanation. जी, ये आइडिया किसने लगाया? मुझे आवाज से पता नहीं चला कि ये जोहा थी या ये तनीशा थी. जी, who just answered it? Nisha, was it you or was it Zoha? Are you listening? मेरी आवाज आ रही है? चलिए बहरहाल आप मेरा ख्याल बोलने की कोशिश कर रहे हैं लेकिन मेरे पास आपकी आवाज. All right. Tanisha थी. चलें, good. Well tried, बेटा. Zoha and Tanisha, let me tell you, corrosive means corrosion और corrosion को हमने इस chapter के बिल्कुल start में second topic के तौर पे किया था. जब ये metals के साथ react करते हैं तो ये metal को उसके oxide में convert कर देते हैं. Hence the word corrosion. Oxide में या hydroxide में. ठीक, तो ये corrosion का टॉपिक सेकंड टॉपिक है आपकी बुक में चैप्टर नंबर 9 के अंदर ही. तो हमारा corrosive से मतलब ये था metals के लिए. नॉन मेटल्स के साथ भी ये रिएक्शन कर जाता है, नॉन मेटल्स को भी कन्वर्ट कर देता है, लेकिन उसमें हम कोई एक स्पेसिफिक प्रोडक्ट का नाम नहीं लेते. ठीक है. वेल, टॉक अबाउट लिविंग सेल्स, उसके केस में मैं आपको ऑलरेडी बता चुका हूँ. डिहाइड्रेशन यही सामने की डेफिनेशन में थी, तो ये डिहाइड्रेशन मुश्किल नहीं होनी चाहिए. पता नहीं इस वक्त बच्चों ने डिहाइड्रेशन को यहाँ से क्यों नहीं देखा. वेल, इन ऑर्डर टू प्रूव इट अ डिहाइड्रेटिंग एजेंट हम कॉन्सेंट्रेटेड एसिड को लेते हैं, डेमोन्स्ट्रेट करते हैं लेबोरेटरी में बाय इट्स रिएक्शन विद शुगर या सुक्रोज. Sugar a carbohydrate है. Carbohydrate by its definition contains carbon, hydrogen, and just let me clear all the drawings and let's move on to next page. By its all drawings contain oxygen, carbon, and hydrogen. The concentrated acid removes hydrogen and oxygen as water. वो water के तौर पे उसे remove करता है, just leaving carbon behind. So as the example of sucrose, I hope you remember the formula of sucrose from biology. That was C12H22O11. हर कार्बोहाइड्रेट में खासियत होती है कि उसके अंदर H और O जो होते हैं वो वाटर की फॉर्मेशन के हिसाब से 2:1 होते हैं और उसके अंदर एक स्पेसिफिक अमाउंट कार्बन का होता है जिसकी रेशियो कोई भी फिक्स रेशियो होना जरूरी नहीं है. वो डिफरेंट कार्बोहाइड्रेट्स में डिफरेंट काउंटिंग में होता है. So what happens that it takes out all hydrogen and oxygen in the form of water molecules and just leaves carbon behind. That carbon is actually the carbon that is left when it reacts with paper or clothing or wood in a similar way. Okay? So this is the reaction. We call it a coal tower reaction. ये देख रहे हैं, ये पीछे जो बच गया ये प्योर कोयला है, ये सॉफ्ट कोल होता है और ये टावर सा बिल्ड कर लेता है, तो हम इसे कोल टावर रिएक्शन कहते हैं. हम एक बहुत कॉन्सेंट्रेटेड सा सोल्यूशन बनाते हैं शुगर का, या हम अगर सर्दियों में ये एक्सपेरिमेंट कर रहे हो अपनी क्लास के अंदर, ये लैब के अंदर बाकायदा परफॉर्म करते हैं. आप नहीं करते बिकॉज अभी आपको कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड हैंडलिंग नहीं आती, ये मैं परफॉर्म करता हूँ. बच्चों को थोड़ा दूर रखते हैं दिस बिकॉज दिस एक्चुअली कम्स अप विद अ लॉट ऑफ स्मोक which may incur coughing in children. ठीक है, तो मैं इस एक्सपेरिमेंट को करता हूँ और हम इसमें बहुत कॉन्सेंट्रेटेड, बहुत ढेर सारी चीनी या बहुत ढेर सारा शुगर केन सिरप या बहुत ढेर सारा ग्लूकोज या सुक्रोज जो हमारे पास लैब में मौजूद होता है, नॉट ईटेबल दो, यू कांट ईट दैट और ड्रिंक दैट. ठीक है, इसका सोल्यूशन बनाते हैं, फिर हम उसमें स्लोली कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड ऐड करते हैं और वो उसके अंदर से सारा वाटर रिमूव करके इसे प्योरली टर्न कर देता है एक ब्लैक कलर के कोल्ड टावर में, और ये टावर इसी तरह से स्ट्रेट जाता है until ये डिसबैलेंस और बाहर को गिर जाए. ठीक है, तो ये हम करते हैं एक्सपेरिमेंट और ये बड़ा एक अच्छा एक्सपेरिमेंट है। ये आपकी आंखों आपको नेकेड आई ऑब्जर्वेशन में शो करता है कि डिहाइड्रेशन कैसे होती है, स्पेशली इन कार्बोहाइड्रेट्स। ठीक है, is that clear, beta? Does anybody has a question about it? If you have a
No,
question,
sir.
please ask. Okay, good, good. We'll perform the experiment. This is usually the end of our experiments. हम इसे सबसे end पर करते हैं, ठीक है? So let's move on to the next industry, the chlor-alkali industry. Now, in case of chlor-alkali industry, this book gives actually a little bit extra information. So I'm going to read through the material, but we are going to skip a few parts out of this. Before I move on to the details with this industry, let me tell you, it is the same industry that we did back in chapter number 4. Clear? This is an electrolysis based industry, और हमने चैप्टर 4 में जहां पर इलेक्ट्रोलिसिस पढ़ा था, हमने वहां पर इस इंडस्ट्री को कवर किया था, ठीक है? So before I move on to this industry and I discuss the details of this industry, I'll actually like to revise chapter number 4. So मैं ऐसा कह रहा हूँ कि मैं इसी बुक में चैप्टर नंबर 4 पे वापस जा रहा हूँ, मैं पेज नंबर अभी निकालता हूँ और फिर मैं आपको डिफाइन करता हूँ कि आपने किस पेज नंबर पे आना है. So you're going to manually come to that specific page number. Just a minute. Let's just quickly skim through the pages to get to that chapter, so to get to that topic specifically. All right, let's see what page. This is page number 109. Let's come to page number 109, the bottom right-hand side of page number 109. When you arrive at this page, let me know so I can get started.
Yes, sir.
All right, ready?
Yes, sir.
Okay, so electrolysis of concentrated sodium chloride solution. Let me revise a little bit. Concentrated solution of sodium chloride contains a lot of salt, the table salt we eat every day, but a little bit of water. Then we electrolyze it in lab or actually in an industry. There are 4 possible ions present. The positive ions are the cations are sodium ion and hydrogen ion, and the negative ions are the chloride ions or the hydroxide ions. I hope you're familiar with that. Okay. So these are the ions. When we talk about lab, we perform it in lab in a different way, but we're not going to go with the lab process here. I'm actually going to come to page 110. Please come to page 110, bottom left-hand side. Now, this type of electrolytic cell in which salt and water are used is actually known as electrolysis of brine. The modern membrane cell is the safest for environment and uses least electricity. Other types of this cell use either a flowing mercury cathode or a diaphragm, a partition, or a membrane which is made out of asbestos. Okay, I'll clear what asbestos is a little later. Okay. The membrane cell has a titanium anode. This I specifically taught in detail. मैंने आपको अच्छी तरह से पढ़ाया है, याद करवाया है, and I remember giving this question in exams. Do you remember that? मैंने बड़ी डिटेल में
Yes.
ये पढ़ाया हुआ है, एनोड, कैथोड, इसकी डिस्कशन, ये सारा कुछ. Titanium anode, nickel cathode. Titanium is chosen for anode because it is not attacked by the chemicals present in the system, specifically chlorine. The anode and cathode compartments are separated by a membrane. It can be called a membrane or a partition or diaphragm, which is actually made out of asbestos. It can be made out of other materials as well. This is selective membrane. It allows sodium ions and water to flow through it, but no the other ions, which means it does not allow chloride ions or hydroxide ions or hydrogen ions to pass through it, right? So looking at this diagram, these are two separate compartments. One is the anode compartment as written. The one on the right is the cathode compartment. The anode compartment gives out chloride ions in form of chlorine gas from the top. The cathode compartment, the right-hand side compartment, gives out hydrogen gas from the top. On the left-hand side, the brine comes in. Sodium and water ions can pass through the membrane in the center. It can be a membrane, it can be a partition, it can be a diaphragm made out of asbestos, or it can be simply ion exchange membrane. There are many types for this membrane. Okay, we'll discuss that later in chapter number 9, not now. And we get sodium hydroxide solution out of it, which is made from sodium ions passing through this and hydroxyl ions, which are left over here. All right. So there were 4 ions. Hydrogen ions, H positive, they go out in the form of hydrogen gas. Chloride ions, they go out in the form of chlorine gas. The 2 left ions are sodium ions and hydroxide ions, which react together and move out of this tap from the bottom right-hand side in the form of sodium hydroxide. So all 4 ions go out of the system in 3 specific forms. Number 1, hydrogen gas from cathode compartment. Number 2, chlorine gas from anode compartment. And from the bottom, we get sodium hydroxide solution. So there are 3 products to the system. No matter what kind of partition or membrane or diaphragm we use, we always get these 3 products. Now, are we all on the same page? Do we know the reactants?
Yes, sir.
There are 2 reactants, water and salt. There are 3 products, chlorine gas, hydrogen gas, and sodium hydroxide solution. And the system is bifurcated into 2 compartments, anode and cathode, which are actually separated by a membrane or a partition or a diaphragm, what we call it, which can be made out of an ion exchange system or asbestos for that matter. All right. If we all understand this portion so far, then we can also understand the stuff that is about to come in chapter number 9. So what I'm going to do is that I'm going to come back to chapter number 9. Let me just quickly screen through the pages and come to the exact page we were at. This is chapter number 10. Let's come to chapter number 9. So this was the page we were at, the chlor-alkali industry. Now, you must be thinking, why are we giving this the name chlor-alkali industry when we have the name electrolysis of brine in chapter number 4? Okay, right? In chapter number 4, the heading was electrolysis of brine or electrolysis of concentrated sodium chloride solution. So the words are also written over here, electrolysis of concentrated sodium chloride solution, which is known as brine, but we call it chlor-alkali industry. Why? This industry had 3 products. One was chlorine, hence the word chlor. Second one was hydrogen, not written or mentioned over here. Third one was sodium hydroxide, and sodium hydroxide is one of the best alkalis in the world, hence the name chlor-alkali industry. You might want to write it down. Chlor comes from the product chlorine, and alkali comes from the product sodium hydroxide. If you want to write it down, you may write it down. Take a few seconds. Let's come to the type of electrolytic cells we have been discussing back in chapter number 4, and we are also supposed to discuss it over here. Although I'm going to go through this detail over here, but in exams, the only thing they are going to ask from is just 2 or 3 names that we're going to discuss. So the rest of the information is just information and has never been used in past papers. Okay, not at least from 2003 till 2019. All right. So mercury cathode cell, the sodium is produced at, dissolves in flowing mercury with it at the cathode. Sodium hydroxide is produced by treating the sodium mercury cathode material with water. Mercury is separated and we get pure sodium. We get sodium reacted with water to form sodium hydroxide. These are the details you do not need to remember. Mercury cathode cell is the only name you need to memorize. So you may cut out this part. That's fine. Diaphragm cell. The diaphragm cell is the cell in which the system is separated by a diaphragm or a membrane that is made out of asbestos. Now here comes the point where we need to explain asbestos. I hope I explained the word asbestos back in chapter number 4, but I'm also going to explain it again. There is some meshy, wiry kind of substance that we use that is known by the name of asbestos that is usually inert or unreactive. एस्बेस्टॉस के लिए आप अनरिएक्टिव का वर्ड जरूर नोट कर लें अपने पास बुक में, ठीक है? And you might have seen asbestos in foot mats. पास मरतबा रूम्स में दाखिल होने से पहले या वॉशरूम के बाहर हमने फुट मैट्स रखे होते हैं जो एक वायरी से मटेरियल के, मेशी से मटेरियल के बने होते हैं. छोटी छोटी प्लास्टिक वायर्स टाइप हमें वो लग रहे होते हैं. बाज़ दफा हमने क्लॉथ या टॉवल बेस्ड फुट मैट्स भी रखे होते हैं, लेकिन बाज़ दफा प्लास्टिक बेस्ड फुट मैट्स रखे होते हैं. That isn't plastic. That is actually asbestos. I hope you might have seen it. If not at your home, then a good hotel or a good market or a good supermarket or elsewhere, right? Those mats, those foot mats that they usually put at the footstep of the washrooms or the toilets is made out of asbestos. Coming to the next point, membrane cell, most modern system and uses an ion exchange membrane. What's an ion exchange membrane? We are not going to discuss that in detail over here, but the only thing you might need to understand, and that is also given on page number 110, is that it has a selection criteria. It allows a few specific ions to pass and stop all the rest. Like back on page number 110, I just told you it allows sodium ions to pass and water molecules to pass, but it does not allow chloride ions, hydroxide ions, and hydrogen ions to pass. So hence the name ion exchange membrane. Right? I usually explain जी.
सर आपने कोई पार्ट कट करने को कहा था?
जी मेरा मैंने कहा है और मैं भी दोबारा रिपीट भी कर देता हूँ, डोंट वरी. ठीक है?
Thank you, sir.
हाँ. I usually explain this ion exchange membrane by taking a few words from biology. I hope आपने membranes biology में study की होंगी और आपने types of membrane भी biology में study की होंगी. Let me take a few names so that it can joggle your memory. Permeable membrane, semi or partially permeable membrane, and impermeable or non-permeable membrane. Do you remember these words from biology?
Yes, sir.
ठीक है? आपको याद होगा बायोलॉजी में आपको मिस सायरा ने बड़ी अच्छे तरीके से बताया हुआ that permeable membrane allows everything to pass through it, and non-permeable membrane allows nothing to pass through it. However, semi-permeable or partially permeable membrane is a type of membrane which allows a certain types of ions or molecules or particles to pass and blocks the rest. Actually, उसके अंदर जो holes होते हैं उनका एक size होता है, तो size से छोटे particles उससे cross कर जाते हैं और बड़े particles stop कर जाते हैं. I hope ये biology teacher ने आपको ये तीनों के लिए explanation दी होगी. पता है?
Yes, sir.
Good, good. Then I hope this selective ion exchange membrane is very easy to understand, as it is pretty much similar to partially permeable membrane. Understandable?
Yes, sir.
Now, what are you going to cut and what are you going to keep? Keep the name memory cathode cell in mind, but cut the paragraph written next to it. You're not supposed to memorize it. In all the reference books of IG and in the syllabus document, this information is extra and never have been a part of past paper. However, the name mercury cathode cell is something that you need to memorize. Next, diaphragm cell is the name you're going to memorize, and you're also going to memorize that the diaphragm is made out of asbestos. That's about it. In case of membrane cell, you're going to memorize selective ion exchange membrane. That's about it. All right. So these are the three portions. In these three processes, we have a anode and a cathode, and there are 4 kinds of ions, and these 4 kinds of ions come together to give 3 products. I've already discussed this part. In Britain, the industry is Cheshire salt deposits. The salt is brought to the surface by both underground mining and solution mining. One factory in Cheshire actually uses 1%. I hope I'm taking the pronunciation of this name right. Is whether it's Cheshire or Cheshire, whatever that is. But 1% of the entire UK electricity output just to electrolyze brine. And that's a huge amount of electricity. UK is one of the countries of the world which are producing a huge amount of electricity for its consumption, and 1% of UK's consumption is too big for an industry to use. So keep that in mind, that electrolysis is an expensive process because of the consumption of electricity. Okay, the class is about to end in 20 minutes. Okay, 20 seconds. So take care, beta. Allah Hafiz.
खुदा हाफिज।